Hello, and welcome to Philip Brown's Computer Networking Lab. You're watching the instructional video called Rapid STP Overview. In previous videos, we have looked at the spanning tree protocol. There is an improved version called Rapid Spanning Tree Protocol that provides a significant faster spanning tree convergence after a topology change. It introduced new convergence behaviors and bridge port roles to do this. We will be looking at them in more detail in a future video. We have two groups of network switches. On the left side, we have three switches running standard spanning tree on them, and on the right side, we have three switches running rapid STP on them. In a moment, we're going to see how long it takes for them to converge. While standard spanning tree takes from 30 or 60 seconds to respond to a topology change, rapid STP is typically able to respond to the changes within 6 seconds of indirect link failures or within a few milliseconds of a direct physical link failure. Rapid spanning tree was designed to be backward compatible with standard STP. Spanning tree works best when it is configured on all the switches. The spanning tree mode rapid PVST command is used to configure rapid spanning tree onto the entire switch. Let's run a series of networking labs and see how the access layer switches in both groups react. First, let's turn on all the switches. It took about 2 seconds for the switches configured with rapid STP to converge. The switches configured with standard spanning tree still have not converged. After about 30 seconds, the standard spanning tree has also converged. I am going to make a direct link failure by shutting down the interfaces between the root switch and the access layer switch. Let's see how long it takes for the switch to converge. The link lights on the switches with rapid spanning tree configured on them converged almost immediately. This is because the access layer switch root port interface is physically down, and so the only way for the access layer switch to contact the root switch is if one of its alternate ports is unblocked. The switch using normal spanning tree took about 30 seconds to converge. Now, let's create an indirect link failure by shutting down the interfaces between both root switches and the backup switches and see how long it takes for the switches to converge. Take a look at the link lights on the right group of switches. They have rapid spanning tree installed on them, and they have converged in less than 2 seconds. The link that was blocked by rapid spanning tree is now in the forwarding state. Finally, the group of switches on the left that has the standard spanning tree configured on them has now converged. It took about 30 seconds. Rapid STP is a useful tool in maintaining networks that quickly adapt to link failures. In an all Cisco network, rapid STP is the preferred choice. I hope this video was informative and I thank you for viewing.